Hello, good day everyone. So this is Teacher Rodel. We're going to learn something new today about calculus, which is the product rule and quotient rule. So first, the formula, uh, the derivative of y with respect to x of u times v is equal to u times dv dx plus v times du dx, or the derivative of u with respect to x. So in simpler terms, the derivative of u times v is equal to u dv plus v times du. So, example, we have given y is equal to x cubed plus 2x times the quantity of 2x minus 1. The formula is u times v is equal to u dv plus v du. So we have two methods here. The first one is, of course, applying the product rule, and the second one is the simplification, or multiplying everything in the given if it is possible. Now, since this is product rule, we need to identify which one is u and which one is v, so that we can assign or solve which one is du, or derivative of u, and which one is dv, which is the derivative of v. Now we let u as the leftmost part of the equation after the equal sign. So u is equal to, of course, uh, x cubed plus 2x. Now if we get the derivative of u, which is du, that would be equal to 3x squared plus 2, and v is equal to 2x minus 1, which is the rightmost part of the equation after the equal sign. So the derivative of v is equal to 2. Now, since everything is complete, the u, the duv, and dv, we now need to apply the formula. So u is equal to x cubed plus 2x, wherein our v or dv is equal to 2 plus v, which is 2x minus 1, times du, which is 3x squared plus 2. Now, simplify. We have the y prime, or the first derivative of y, is equal to 2x cubed plus 4x plus 6x cubed minus 3x squared plus 4x minus 2. And then, after combining like terms, we have y prime, or the first derivative of y, is equal to x cubed minus 3x squared plus 8x minus 2. Now, the second method, or the simplification process, first, we need to multiply again and again the given, and then applying the sum and difference rule. So we have y prime is equal to 4 times 2 times x to the power of 4 minus 1 minus 3 times x to the power of 3 subtracted by 1 plus 2 times 4 times x raised to the power of 2 minus 1 minus 2 times 1. Or simplifying it, we have the first derivative of y is equal to 8x cubed minus 3x squared plus 8x minus 2. So either of the two methods, the result is the same. Now for example number 2, we have the given y is equal to x cubed minus 3x squared times the quantity of x squared plus 4x plus 2. So again, here is the formula for the product rule, and then method 1, we apply the product rule. So we let u equal to x cubed minus 3x squared, and du, the derivative of u, is equal to 3x squared minus 6x. Now, v is equal to x squared plus 4x plus 2. So, getting the derivative of v is equal to 2x plus 4. Now, applying the formula, no, u times dv plus v du. So multiplying, no, x cubed minus 3x squared subtracted, multiplied rather to 2x plus 4 is equal to 2x to the fourth minus 6x cubed plus 4x cubed minus 12x squared. Now the right hand part is x squared plus 4x plus 2 times 3x squared minus 6x. So if we multiply the 2, the result is 3x to the fourth plus 12x cubed plus 6x squared minus 6x cubed minus 24x squared minus 12x. Now, if we simplify, the result is this one, 2x to the fourth minus 2x cubed minus 12x squared plus 3x to the fourth plus 6x cubed minus 18x squared minus 12x. Now, combining like terms, finally the result and our final answer is y prime is equal to 5x to the fourth plus 4x cubed minus 30x squared minus 12x. So as mentioned earlier, we have another method. This is simplifying first the given or multiplying first the given. So simplify first. Uh, After multiplying the two quantities, here is the result. Y is equal to x to the fifth minus 3x to the fourth plus 4x to the fourth minus 12x cubed plus 2x cubed minus 6x squared. And combining like terms, the result is y is equal to x to the fifth plus x to the fourth minus 10x cubed minus 6x squared. And finally, getting the derivative of it, the result is y prime is equal to 5x to the fourth plus 4x cubed minus 30x squared minus 12x. Again, the result or the answer is still the same. However, not all given, not all product rule can be multiplied or can be simplified. So I am just trying to show that two methods is applicable if the given equation can be simplified or can be multiplied. However, if it is not possible, then the only resort is the method 1, which is the product rule. Now, let's go to the derivative of a quotient or quotient rule. So simply in this case, we need to have just a numerator and denominator so that it would qualify as a quotient, no? Or we can apply quotient rule in this case. So the derivative of y with respect to x, if the given is u over v or quotient or a fraction, so the formula is equal to v times du dx minus u times dv dx all over v squared, or simply the derivative of u over v is equal to v du minus u dv over v squared. Take note that v du means v times the derivative of u, and u dv means u times the derivative of v. Now, we have the given y is equal to x squared plus 1 over x cubed minus 1. So again, we need to use this formula and apply the formula. So we let u be the upper part or the numerator. So u is equal to x squared and the derivative of our u is equal to 2x. Now our v is the denominator, which is x cubed minus 1, and the derivative of v is equal to 3x squared. So we now need to apply the formula since the details are complete: u, du, v, and dv. So y prime is equal to, let's talk about the upper part first, x cubed minus 1, which is our v, times du, which is 2x, subtracted by the product of u times dv. So x squared plus 1 times 3x squared all over v squared rather, which is x cubed minus 1 squared. So simplifying, we have 2x to the fourth minus 2x subtracted by 3x to the fourth plus 3x squared all over x to the sixth power minus 2x cubed plus 1. And then if we simplify further, so that means we need to distribute the negative sign to 3x to the fourth and 3x squared. The result is 2x to the fourth minus 2x minus 3x to the fourth minus 3x squared all over x to the power of 6 minus 2x cubed plus 1. So finally, after combining like terms, we will have y prime is equal to negative x to the fourth minus 3x squared minus 2x all over x to the sixth power minus 2x cubed plus 1. Or we can rewrite this by factoring out the lower part or the denominator by writing, and also the upper part by factoring it by getting the common nominal factor, which is x. So finally we have the result of y prime is equal to the negative x times the quantity of x cubed plus 3x plus 2 all over x cubed minus 1 raised to the power of 2. So in this case, for the quotient rule, we don't have uh, method. We don't have two methods. We only have one. We only have one formula. So in this case, we need to apply always the quotient rule. Now, second example, this is quite interesting because the upper part could be considered as product. So y is equal to the quantity of x squared minus 1 times the quantity of x plus 1 all over x squared minus 2x plus 1. So the formula again is the quotient rule. So here we can apply two formulas, product and quotient, but the simpler thing to do, which is the idea of mathematics, because in math we don't make simple things complicated, but the reverse, which is making complicated things simple. So we are going to simplify first, no, the numerator. So by simplifying it, we will have the factor, no, of x squared minus 1 is x minus 1 times x plus 1 times, of course, the original given, which is x plus 1, and the factor for the denominator is x of x squared minus 2x plus 1 is x minus 1 times x minus 1, which means that we can cancel out x minus 1. So therefore we now have the numerator of x plus 1 times x plus 1 all over x minus 1, or x squared plus 2x plus 1 all over x minus 1. This could also be written as, I am referring to the numerator, this could also be written as x squared, x plus 1 squared, or x plus 1 to the power of 2, since x plus 1 is being replicated twice. Now, since I opted to write it in a non-factored form, which is I simplified everything, so we let u be equal to x squared plus 2x plus 1, which has a derivative of 2x plus 2, and our v, the denominator, which is x minus 1, which has a derivative of 1. Now, since all the details are complete, we now need to apply and, of course, simplify if it is possible. So y prime is equal to x minus 1, which is our v, times du, which is 2x plus 2, subtracted by the product of our u, which is x squared plus 2x plus 1, times 1, all over x minus 1 squared, as the formula states, because it is v squared. Now, simplifying, we have 2x squared minus 2x plus 2x minus 2 minus x squared plus 2x plus 1, because subtracting any number by 1 is the number itself, all over x minus 1 squared, which is, after simplification, or writing it into non-factored form, which is x squared minus 2x plus 1. So we need to combine like terms and simplify. So 2x squared minus 2 subtracted by x squared minus 2x minus 1 all over x squared minus 2x plus 1, and finally the result is x squared minus 2x minus 3 over x squared minus 2x plus 1. So my dear students all around the world, so I hope this helps. Just a tip, no? You can pause, you can rewind, or you can forward, or anything you wanted. You can screenshot as well, so that everything will be in your pace, at your pace, and you will be guided accordingly. If in any case you have questions, you can email me at rodel pipito22@gmail.com, or that should be also written at the description below of this video. So you can also try the following examples, no? We have not examples but exercises. We have 4 exercises here. Number one is product rule. Numbers 2, 3, and 4, you can apply quotient rule. And of course, if in any case you can simplify before applying a certain rule, then that's better. Now, for the answer key of this, you can just email me so that I can give you the answer key and of course the solution. And if that is, if your answer is correct, then that's good. And if your answer could sometimes be incorrect, then that's also good because by that you're learning something. Okay? So thank you so much for listening and God bless. Not just you, but all of us. God bless us all. Thank you.